Hi everyone, Mrs. Vara here with a video for lesson 7.1, common logs. So you're going to find common logs, solve common logs, and use change of base formula. Here's a warm-up that you should do on your own. So a common log, what you want to think is, it is the log in your calculator. So if you need to do a log in your calculator is always base 10. So it's programmed into your calculator and written as log m. So when it's base 10, often we don't even write the base. And if you look at your calculator, your log button just says log. And you have one on this calculator too, right here, just says log. It's base 10. It's always base 10. So calculator is always base 10. So when we have a different base, that's when we use the change of base formula. These logs right here, notice the base isn't written, but that means it's base 10. So this is the same as log base 10 of 6. And so you can evaluate this or find the value for this in your calculator. So you'd simply go in this calculator, you're just going to find the log button and hit log. Let's turn it on first. Log of 6, put your right parenthesis in, and you're going to get a decimal. And I think throughout these notes we are going to use 4 decimal places. So log 6 is 0.7782. So this is 0.7782. So that's simply all you're doing for these is putting them in your calculator. So I'll use the 83 for this one. So I'm going to do log of 0.35. So on this calculator, here's my log button right here. Show you my screen, and I'm going to do 0.35, right parenthesis, and I get a negative, which is fine, negative 0.4459, 4 decimal places. Alright, so these are for you to try. I think you can handle those. Just punch them in your calculator. Alright, let's get on to what happens when your log does not have a base 10. So this is what we call the change of base formula. So the reason we need to use change of base is if we have a log that is not a base 10, but we want to solve it putting it in our calculator. So this is useful because now we can rewrite any log as a base 10. So this is the formula. Here's what it kind of looks like in reality. So I'm just going to make one up here. Log base 4 of 14. So this is a base 4. I can't put this in my calculator. So I can use the change of base formula, and what I would put in my calculator is log of 14 divided by log of 4. So the way I remember this is when you look at this, see how it looks like 14 is above 4? So the fraction on the top is log 14, so 14 goes above log of 4. Okay, so it's 14 over 4. So when you write this, 14 looks above 4, so when you put it in the fraction, do log of 14 over log of 4. Now these are both base 10, so then I can punch this in my calculator. So we'll do a couple of those right now. So here's our first example. Express each log in terms of common logs, so that means base 10. But remember, we don't write base 10. Then approximate its value to 4 decimal places, so then we're going to put it in calculator. Okay, so first I'm going to notice 16 is above 3. So in a common log, this is going to be log of 16 divided by log of 3. Remember, I'm not writing that base 10, but it is base 10. That's like the invisible base. So now I'm going to go to my calculator, and what I'm going to put in is log of 16. You have to use that right parenthesis or you'll get the wrong answer. Divided by log of 3, right parenthesis, and I'm going to get 2.5237. So both of these I can say is equal to 2.5237. So that's also this. Okay, so it allows you to find any value for a log, even that's not base 10, in your calculator. So let's look at another one. 50 looks like it's over top 2, so I'm going to write a fraction of log of 50 divided by log of 2. Let's get in the habit of wrapping those up in parentheses when we write them. Should have done it back here. So then we know when we put it in the calculator we have to do the same thing. I'll use this calculator this time just for variety. So log of 50, right parenthesis, divided by log of 2, right parenthesis, and I get 5.6439. So log 2 of 50 is that number, and this is how I find it using the calculator. I have to do the common base. So try these on your own. Yeah, pause the video, try these. Alright, if you're coming back now, this is what you should have written down. And what you should get is 1.8613. So try that one. I'll check them when I'm in class tomorrow. Make sure you got those right. Alright, so why do we need to do this? Because we need to solve equations just like we had been doing in Unit 6. I want you to know that Unit 6 and Unit 7 are really the same. It's just more logs and exponentials. They could be the same unit, and in any algebra book they would be the same chapter. So now we're solving, but when we were solving these, we're used to getting a common base to solve these. When our variable is stuck up here as an exponent, we would use our cheat sheet, get a common base, and then set our exponents equal. But in the problems we're going to look at today, you cannot make a common base. So these are the steps we're going to use. First of all, we're going to rewrite it as a log. So we're going to do our arrow thing. Starting to think of this as kind of my rock and roll. Rock and roll. So log base 5 of 62 equals x, right? That rewrite thing we've been doing all through Unit 6 and now in Unit 7. Now x is equal to this. So I can solve for x. I just have to figure out what this is equal to. Well, I cannot put this in my calculator, but I can change it to the common base. So 62 over 5. Log of 62 over log of 5. Let's get in the habit of doing those parentheses. And that is equals x. Keep working down your equation here. Now I'm going to punch this in my calculator. So I'm going to do log 62 parenthesis divided by log 5 parenthesis equals 2.5643. So in this case, x, all this time I had x on the right, equals 2.5643. So there I solved. So a couple of things, these equations are all solved. They have an equal sign, they have a variable, so your answer should look like x equals a number. Alright, let's try this one. Can't get a common base between a 7 and an 11. So I want to rock and roll here, rewrite this as a log. I'm going to put that in parentheses, and this is going to be log base 7. Remember, exponential base 7, log base 7. Log 7 of 11 equals 2x plus 1. Now, I'm solving for x. So this time, unlike this problem up here, on the right side I don't have equals x. I have equals 2x plus 1, but that's okay. It's just a simple Algebra 1 problem. First I need to figure out what this is equal to though. So I want to change it to the common log. Log of 11 divided by log of 7 equals 2x plus 1. Keep that right side. It's not equal to x in this one. Put this in your calculator. So again, log of 11 divided by log of 7 equals, kind of hard for you guys to see, there we go, 0.5352. Log of 11 divided by, oh, I hit the wrong button here. Let me try that again. Log of 11 divided by log 7. There we go, 1.2323. We're going to use 4 decimal places every time here. So on the left side, log of 11 divided by log of 7 is 1.2323 equals 2x plus 1. Now continue solving for x. So I want to subtract 1 from both sides. Well, 1.2323 minus 1 is just going to be 0.2323 equals 2x. And now I want to divide both sides by 2. If you still have this number in your calculator, then you can just do minus 1. There's my 0.2323, and then I can do divide by 2. So don't clear your calculator out on these. And I'm going to get 0.1161 or 62, depending on how you rounded. 0.1161 equals x. You're going to get decimals for all of these problems. Okay, so let's see. I guess I have one more, and then a couple for you to try. Okay. So 4 and 16. Hey, I'm thinking I could do a common base for this one. So I'm going to solve this one 2 ways, and then you can see that we get the same answer. So this, I'm thinking, well, wait a minute, I can use our old method for, what's happening to my camera here? I better use my pen. 4 to the x minus 1, I can write 16 as 4 to the second power. Common bases, I can set my exponents equal, add 1 to both sides, so I should get x equals 3. Now let's do it with our new method and see what we get here. So change to a log, so rock and roll. Log 4 of 16 equals x minus 1. Okay, change this into a common log equals x minus 1. So log of 16 divided by log of 4. Use this one, I think it shows up better on the camera. Log, what am I doing here, 16 divided by log 4. Oh, and look at what I get, 2. Nice round number. So 2 equals x minus 1. Add 1 to both sides. X equals 3. So this is one where we could use our old method, getting a common base. Could use your new method and your calculator. You see you get the same answer. Okay, these are a couple your turns for you to try. I do want you to do these. I will give you the answers so you can check your work. But remember, you can't get a common base on these. So you're going to rewrite them as a log. So do your rock and roll. Then you're going to find the common log. Then you're going to solve. So for this one, you should get, I have the answer right here, x equals 2.5789. So try that one, solve it, see if you get that. And then also try this one. Cannot do a common base here. So you're going to change to a log, rock and roll. Give you a little hint on this one. This is going to be log 6 of 8 equals 4x minus 3. Change it to the common log so you can find the 4 decimal places that log 6 of 8 equals, and then continue solving for x, and you should get x equals 1.0402. So that is it for 7-1, and then you're going to continue on and do these problems on page 6. That's all.